Hi, Tri-Cities Brew Club. This is Aaron. So I wanted to share some of the recent enhancements that I've made to my hot liquor tank as well as my mash tun. I'd like to show a quick demo of a 12-volt pump that I picked up at Beyond the Grape. So with my hot liquor tank, really quickly, what I've had done recently is I've had a 1.5-inch tri-clamp ferrule TIG welded into my hot liquor tank so that I'm able to use my hot liquor tank either with 240 volt electricity, or I could pull off this element housing adapter and put an end cap on to utilize propane. So if I show you the inside here, you can see that I have a Camco 5500 watt 240 volt. I think it draws about 23 amps of power. I don't have it connected right now. My work table here is a little bit of a mess with all the electrical connections. Before I use this, what I need to get is a GFCI just to make sure that nobody's going to get hurt. I've already tested all the connections. There is a short between the element housing adapter and the kettle, so there's no risk of electrocution. But just in case, because I have little kids and maybe if I have a couple beers while I'm brewing, I want to make sure that it's going to be safe for everybody. For part of my phase 1, what I'm going to be doing here is installing a project box, probably 3 feet away from the element adapter along this 10-3 cable. Within that project box, what I'm going to install is a potentiometer as well as a 40 amp SSR that will allow me to throttle up or throttle down the actual current and power that is going to be thrown into the hot liquor tank. So I've done the same thing with a TIG weld for, if I just show you here, my 25-gallon brew kettle. I also have the adapter down here as well, so I can toggle between electric as well as propane for both vessels, which is pretty exciting. But again, more parts are needed to make sure that it's going to be safe. Anyways, what I picked up not too long ago was a 12-volt pump from Beyond the Grape. So what I decided to do was to install a really quick project box that would allow me to turn this pump on and off just with a switch. So if you see down below my workbench here, I have a 12-volt RV deep cycle battery. I've connected it to some really simple alligator clips that is going up through, I believe this is 18-2 wire. I'll have to double check that. But it was a fairly thin gauge, but good enough for 120 volts, but I'm only running 12 through it. What I've done is I've brought that up into a waterproof enclosure. I just put a quick label on here to indicate what this is for. This is a really cool combination of fittings. I've screwed this into my workbench, and if I lift up the cap, I wired it up to a 120 volt switch. So right now it's in the off position. Lifting it up would put it into on, put it back to off. Previously, what I've done with my 12 volt, my other 12 volt pumps, is I've been connecting and disconnecting the wires from the actual battery itself. So this is going to be a little bit more convenient for me, I hope, and it's untested. So as you're watching this video, you're learning everything that I'm learning. The other thing that I've done is to all of my fittings, and rather than using quick disconnects, which can get actually pretty expensive, I found that female quick disconnects locally run about $18, where a male quick disconnect runs about $8. It was actually a lot less expensive to purchase some 1.5-inch tri-clamp fittings with either silicone or PTFE, which is the Teflon gaskets. I use silicone with these because they're nice and tight, they won't budge. However, with the element housing adapter, I use a PTFE so that I'm able to just loosen the tri-clamp, reposition the element if it's not exactly straight, and continue on. So with those fittings replacing the barbs that I had in place, I just used some Teflon tape. This is a male tri-clamp 1.5-inch adapter. It's still connecting into my 3-piece ball valve, which is going into a weldless connector. It's just a matter of time before I get some more TIG welding done for me and make sure that all of this is tri-clamp welded rather than having the weldless connectors. But that's a problem for another day. So I have not tested this configuration, but but what I wanted to do for my 12-volt pump is be able to have whatever the flow is. I want to be able to open up the vessel full throttle on the ball valve, and I want the pump itself to be able to control the output. So what I did here really quickly was put on just a simple single piece ball valve that's connected again to a male threaded tri-clamp adapter. I have this connected to approximately 4 feet of silicone 1/2 inch tubing, which is running over into my my mash tun. So my mash tun again is all stainless fittings that have been put in. It is a weldless bulkhead, again from Beyond the Grape, and again going in from 1/2 inch. So if I'm open up my mash tun, you can see that's all stainless all the way through. I have a little bazooka tube. I think this is about a 38 quart cooler that I use for my mash tun. It's pretty good for the common 5 to 10 gallon US batches that I run. So really the purpose of this video was to demonstrate some of the changes, hopefully get some feedback and some advice as to whether or not this is the best way, whether or not this is safe, but also just to show some of the cool things with the club that we're able to do. So I'm just going to quickly just go back and talk about the electrical connections again. So being a 12-volt pump, it really has the positive and the negative connection. So what I did with this, I believe it's again 18-2 wire, is I just used some heat shrink tubing after I stripped off the connections. I have a really nice fitting going on inside here. I just wanted to make this a little bit more tamper resistant. I don't have, coming from the box, an actual hose, or sorry, a wire catch, but what I did was inside of here I installed a few zap straps. So it's not very possible for, it would take a lot of effort to try and yank these wires out. So I'm not too concerned about the electrical connections on the inside. And again, the purpose of this box is to be waterproof, for me to have quick access to turning on and off this specific pump. So why don't we get into it? I'm pretty excited to see the performance of this pump, whether it works or not, whether or not the wiring that I have set up in this box works or not, and I'll give you some quick feedback on it. So the first thing I'm going to do is I'm going to open up the valve to my hot liquor tank, to my mash tun, and I'm going to open up the valve from my hot liquor tank. I have about 10 gallons of water in there right now. It's sitting approximately 137, 138 degrees Fahrenheit. So it's kind of warm. It doesn't really situate. I see a little bit of steam coming off because it's only about 16 degrees in my garage right now. The element again is soaking in the water. This is about a 15-gallon, 14-gallon total capacity vessel. So again, it's really good for anything up to about 15 gallons for brew size. So what I want to do here really quickly is try and take some of the air out of the pump. So I'm going to open up the valve and see if we can get some flow. This silicone hosing that I picked up, I'm not too happy with it. The biggest complaint that I have with this hosing is that it crimps really easily, and that's probably not going to cause some damage to the pump. It's just going to more or less cause some problems with me. I probably the way that I can best address this, I'm just going to close this for a moment. Probably the best way for me to address this is to put in some 45-degree angle barb connectors rather than using the straight through. That might help relieve some of the pressure that's happening. Again, my intention is not to have this pump mounted directly to the hot liquor tank. I will probably build a small pump caddy that will allow me to have one for hot water and another one that manages the movement of the wort. But that's for another day again. So what I'm going to do is I'm going to open up the valve again from the hot liquor tank. So we're going to have flow from the hot liquor tank just from gravity right now. I'm sure that this mash tun is filling up. Yeah, there's a little bit of water coming through right now. It's pretty slow. Again, this kink is causing me a little bit of problems. So I'll try and push my hot liquor tank back a bit. See if I can. It's really heavy. The pot itself probably weighs about 10 pounds, and with 10 gallons of water, it adds some extra weight there. All right, but let me see if I turn on the switch to the pump. You're going to find out with me if this actually works or not. Wish me luck. So far I'm not seeing any leaks coming through. I am seeing that there is definitely flow of liquid coming through, but I'm not certain that this pump itself is actually operating. So I'm going to pause this, I'm going to check some of the electrical connections, and I'll get right back to you. Alright, so I have the polarity reversed on the pump. You can probably hear it right now going. It's pretty quiet, actually. Now, when there's some restriction on the line, I notice that it gets a little louder, which is to be expected. So I'm also checking for the first time the leaks. I see a little bit of a leak coming out of both ends from the pump, as well as on the both sides of the ball valve itself. So I'm just going to pause this. I'll turn it off. Turn off the switch. There we go. The pump turned off properly. What I'm going to do is just tighten this up, and I'll resume the video. Alright, I'm back. So you can see that the orientation of this valve is a little bit different than what it was a few minutes ago. What I realized was, yes, I did have enough Teflon tape on both sides of the ball valve before the pump and before the tri-clamp fitting. The problem is I just didn't have it screwed on tight enough. So it's tight, the pump is running again, liquid is flowing through. It doesn't seem to have too much restriction. Again, I feel it's really important, and I don't believe it's going to harm the pump to be able to have the throttle following the pump. I hear the pump working a little bit harder. Again, it is a DC motor, it is brushless. I believe it's going to be able to handle that. So this will be nice when we're talking about controlling the speed of flow, specifically when it goes through from a mash tun use, if I'm looking to recirculate the mash, which I normally do. The other thing is going through a counterflow chiller that I've built. I want to be able to slow it down if the wort is not coming out cool enough. So if we take a look at what's happening here inside the mash tun, we can see it's getting pretty full. Though the pump is actually pretty powerful. This is the I believe this is the 15 PV, yep, 12 volt DC. This is one of the higher rated performance pumps that was available from the TopsFlow website. I was really happy that Beyond the Grape was carrying this product because it's really cost effective. It was about $70, and from the overall flow rate that I need within my system, that's perfect. A chugger pump would definitely be overkill for what I'm using. So we're just taking a look here. We're down to probably about, if I were to guess, about 3 gallons left out of the overall 10 gallons of liquid that we put. There is a little bit of a leak still occurring here within my ball valve. You might not be able to see that. And I believe that that was caused when I decided to throttle back. So if I go back about half on the ball valve, yeah, there's some pressure that's building up on both sides still. So I can solve that just by tightening it up a little bit more. Again, what my goal is with this pump is not to be directly connected like this. I believe that this is like a plastic ceramic type frame. It's not going to be able to hold the weight that I want it to. So what I'll do is I'll take from this tri-clamp here to this tri-clamp over here, connect that to a simple trolley type system that will allow me to move the 12 volt battery and the pump wherever it's needed. For my use purposes, again, one pump's usually enough. In a perfect world, I'd have 2. So I'm just going to turn it off. Works great. The battery was about 11 volts of output right now. It seemed to run this pump like a champ. Turning it back on, kicks in really quick. Overall, I'm really happy with it. Yeah, my 10-gallon kettle is almost empty, and it's only been running for a few moments here. So I think overall, fantastic performance. I'm really pleased with the watertight enclosure and how it functions. I didn't realize that you can use a 120 volt switch on a 12 volt system. But for me, it seems to be working. So thanks everyone for watching this. If you have any comments, please let me know. I'm always looking to make things a little bit better and share some of my experiments with the larger team. And have a great night.